Hi, and welcome back. The next algorithm that we want to talk about is the selection sort algorithm. And again, remember, we are only talking about the application of the algorithm. We are not going into details of how to implement the algorithm. If you want those details, you can always go back to our recommended textbook and check everything is there. But for your exam, you are required to know how to apply the algorithm. So given this list, can you sort the list using selection sort? That is all that matters, and that is what we'll talk about here. So, selection sort, what it does is it looks at your whole list and it finds the smallest item in your list, and then it says, okay, since I found the smallest item, this has to be the first item in my list. And then that means it moves that item, which is the smallest, to the first index. And that means the first index is now sorted, which means we then repeat the same procedure, but starting from the second index to the last index. We then find the smallest item in that sub list, and then we move that to the second index, and we keep doing that until the whole list is sorted. So, the running time for selection sort is n squared, which means it's not very efficient. And because you always have to find the smallest item in each sublist as you keep sorting, the number of comparisons that selection sort does is really a lot if you compare it with insertion sort. So I would also recommend you to look at the insertion sort video, because you always have to, when you're trying to find the smallest item, there are going to be a lot of comparisons that happen in order to find the smallest item. And that is why it makes a lot of comparisons. But what you do, once you find the smallest item and you want to move that to the index it should go, you don't have to make a lot of movements. You just swap that current item with the index where it needs to go. So in summary, selection sort makes a lot of comparisons, but it also makes less movements compared to insertion sort. And if we take, for example, a list like the one that we have here, we've got this whole list of 7 items, and the first thing is we say, what is the smallest number in this list? We pick 5. And then we know, okay, since 5 is the smallest, 5 needs to be at this index, which means we then swap 5 with 16, and 16 comes here, 5 goes here. And that means we don't have to worry about this portion of the array anymore, because we know that it's sorted, which means we start focusing on the remaining list. So selection sort keeps this portion of the array that is sorted, and it keeps another portion of the array that is unsorted, which means on the next iteration, we are now looking at this unsorted list and we say, okay, what is the smallest number here? Because that number needs to go here. So we look at this unsorted list, we find 7, and so 7 needs to go there. So we swap 7 with 30, 7 goes there, and then we are remaining with this, because we are saying now we don't have to worry about this portion of the array, because this here is now sorted. That is how selection sorts. So you keep doing this until you get here, because once there's only one item remaining, and a collection with one item is already sorted. Okay, so you keep doing that until the unsorted list is now a size of 1, because it means everything has been sorted. So let's look at an example. I think there's not much to explain here, but basically the algorithm is to find the location of the smallest index. In other words, where do we need to put the next smallest item inside our unsorted list, which means from our last index to the final index, this is our unsorted list. And once we find it, we swap that smallest number with our index that is representing the first index in the unsorted list, in this case being referred to as index, and smallest index being the index with the item that we have found to be the smallest in the unsorted array. So in terms of application, really, let's just look at an example. You've got this list here. So obviously you want to find an item that goes on the first index by finding the smallest item. So we find that 5 is the smallest. So what you do is you swap 5 with 34, which means everything here remains the same. And we know that this portion of our list is now sorted, which means our index the next index where we need to put our item is this one, which is the first index of our unsorted list. And then in our unsorted list, we say which one is the smallest. We find that 12 is the smallest, right? Yeah, 12 is the smallest. So we need to swap 12 with 67. That means here we still have our 5. So 12 goes here. 23 is still here, but 67 goes here. And we still have 78, 56, 36, 79, 34, 32, 66. And we know that this portion of the list is now sorted. So we look at the remaining unsorted list and we say which one is the smallest item here. We find 23, so we swap 23 with 23, nothing changes. So now we have here 5, 12, 23, 67, 78, 56, 36, 79, 34, 32, 66. So every time you do the iteration, this is what is happening. You just, so this is now sorted, which means your unsorted list now starts from here, going there. And then you find the smallest item, which is 32, which means you swap 32 with 67. So if we do that, we still have 5 here, 12 here, 23, and now your 32 comes here, and your 67 is there. And you have 78, 56, 36, 79, 34, 66. And then we go to the next item. Which one is the smallest? So here we pick 5. We have 12, 23, 32. Now in this sub list, 34 is the smallest. So we swap 34 with 78. So 34 comes here, 78 goes there. And then we have 56, 36, 79, 67, 66. And obviously this part here is now sorted. And then we look, let me just rewrite these numbers. So this array is here, now sorted, 32, 34. Now which one is the smallest? 36 is, so we swap 36 with 56. So 36 goes here, 56 goes there. Now we have 79, 78, 67, 66. And that means this portion here is now sorted. Okay, let's write these ones down. So we have 5, 12, 23, 32, 34, 36. Now in the sub list, which one is the smallest? It's 56. So we swap that with 56. So 56 stays here. We have 79, 78, 67, 66. So in that case, that is that. So let's rewrite these ones. So we have 5 here, 12 here, 23 here, 32, 34, 36, 56. And now we are looking at in the sub list. 66 is the smallest, so we swap 66 with 79. So 66 comes here, 79 goes there. Then we have 78 still here, 67 here. And we can say that this here is now sorted. Next one, we have 5, 12, 23, 32, 34, 36, 56, 66. In the sub list, 67 is the smallest. We swap that with 78. So 67 comes here. 78 goes there. Then we put 79 there. And obviously, this part here is now sorted. So let's repeat these numbers here. 5, 12, 23, 32, 34, 36. 56, 66, 67. Now in the sub list, 78 and 79, 78 is the smallest. So we swap 78 with 78. And this part here is now sorted. But because we are left with only one item in the unsorted array, that means a collection with one item is already sorted, which means this is also now sorted. And eventually our whole list is sorted. So that is how you apply the selection sort algorithm. Here's another example that we want to do on the selection sort algorithm. So we've just done this one. It's a repetition really of what we've just done. We are given numbers and they say, show the resulting array after the first and second passes of the sorting phase. That is the for loop iterations that happen. So if I'm going to rewrite these numbers, I'm going to start here. So you have to find the smallest number in this case, which is 10. So that means 10 has to be swapped with 28, which means you're going to end up with 10, 18, 21, 28, 25, 30, 12, 71. We just put some commas here so that we don't confuse these numbers. 32, 58, and 15. And this part is sorted, which means we now look at the unsorted array and we say which one is the smallest. In this case, the smallest is 12, right? Which means 12 becomes the second index. So you swap 12 with 18. So now you have 10, 12, 21, 28, 25, 30, 18, right? Because we swapped. You have 71 here, 32 there, 58 there, 15 there. And this sub-array here is already sorted. So that is how it looks like in the first and second passes of your sorting phase. Nothing much. Here's another question. This one says, show the state of the array after the fourth iteration of your sorting. So here's your array. These are just the indices or indexes, whichever way you prefer. So we want to obviously start by identifying the smallest number, which is 4. We swap 4 with 43, which means we end up with 4 here, 43 there. We got 7, 10, 23, 18, 19, 5, 66, 14. And then we find the smallest item in the unsorted list, which is 5. So we swap 5 with 7. So we have put 4 here, 5 here, and 7 goes there. Now we've got 10 here, 23, 18, 43, 19, 66, and 14. And obviously this one here is sorted. So now we look at who needs to go there. 7 is the smallest in the remaining unsorted list. So now we've got 4, 5, 7 swapped with 10, obviously. So here there's 23, there's 18, there's 43, there's 19 there, 66, and 14. And this portion is now sorted. Now we look for the number that needs to go here. The smallest in the unsorted array is 10. So we swap 10 with 23. So we have 4, 5, 7, 10. 23 is there. 18, 43, 19, 66, 14. And that there is your answer. Because they wanted what it looks like after the fourth iteration. So after the fourth iteration, that is what it looks like. So that selection sort for you, it's not very difficult to apply. You just have to understand how it works and you apply it. Otherwise, that's it. Next up, we are going to look at the selection insertion sort algorithm, which sort of has the same running time as selection sort. So yeah, I'll see you there.